Okay, so welcome, and now we'll be looking at the top 10 skills in demand. The top 10 skills in demand. And the top 10 skills we are trying to understand here is data visualization, quality assurance engineer, project management, programming, AI and machine learning, cybersecurity, UI UX, data science, digital marketing and software development. So I'll be explaining them one after the other so you can understand what this field is all about, and you can be able to know the aspects you would want to dive into. So let's go. Data visualization. So if you ask yourself, what is data visualization? Data visualization refers to the graphical representation of data and information using charts, graphs, and other visual elements. Data visualization is used to effectively communicate complex data sets in clear and concise way. So you can communicate complex data sets that amount in thousands, in millions. You can be able to use your chart, you can be able to use your graph to explain those data sets in a clear and concise way, and you make it easier to understand and interpret. You make the information on the chart easier to understand, you make it easier to interpret. Data visualization is often used in businesses, is often used in scientific research and other fields where large amount of data need to be analyzed and communicated. The common types of data visualization include your bar chart, your line graph, your histograph, your heat map, etc. Most of these things that you do in statistics at school, or you do in your, I think sometimes you do it maybe in statistics, in mathematics. You can find those bar charts you were plotting, those histograph you were plotting, and those line graph and so on you were plotting. Those are what the elements that we bring together in order to understand data, in order to understand information and interpret them um, very well. So if you know you are good in analyzing data, you are good in data visualization, you are good in communication, data visualization is a very good part for you. Now let's look at the quality assurance engineer, QA. We call it QA. QA, or quality assurance engineer, is responsible for ensuring that software products meet the required quality standard before they are released to the public. So a QA role is to identify and is to resolve defects and bugs in software application and conduct tests to ensure that the software function as intended. So in software development, we have something we call the requirement document. We have this requirement document is a document that specifically lists out all the requirements that this software should have. Now, a software engineer is the one that sits with this requirement document and is able to test the software. He writes test cases, both in automated test cases and manual test cases, and is able to understand if this software now and if this software is able to pass the requirements that it is intended to do. So all the functionalities of the software, all the performance of the software, all the performance that software is supposed to do, the quality assurance engineer will test it to know if it follows the requirement. So the quality assurance engineer work closely with developers, they work closely with product managers, they work closely with stakeholders to ensure that the software product comes or it meets customer requirements and are user friendly. A quality assurance engineer is responsible for writing test cases. You write test cases for manual testing. You also write test cases, write test scripts for automated testing. You write test plan. You execute the test script. You document your defects and you report your defects to the engineers. And you also follow up the test to make sure that these defects are being looked at and is being resolved so that your software can be very very good and useful. Don't forget that we looked at data visualization. Now, also in quality assurance, and the quality assurance engineer needed the skill of data visualization, because when you are trying to report defect, you are trying to analyze defect, you are trying to present the result to stakeholders, you need this data visualization in order to do this comprehensively. Let's look at project management. Project management is a process of planning, organizing, and overseeing the execution of projects from conception to completion within a specific time frame and budget. Now let's look at this carefully. When you want to when you the process of conception and completion of a project must always follow a defined and specific time frame, and it must also um, um, fall into the budget that was created for it. So you're not going to you're not going to manage a project that is above the budget that was made for it. So project management involves defining project goals and objectives, identifying tasks and resources needed, and creating a project plan with timelines and deliverables. So those of you that are interested in project management, we are trying to make you understand what you'll be looking at in project management. Project management also involves monitoring project progress. You need to monitor the project progress, monitor what the engineers are doing, monitor and manage risk, communicate to stakeholders, and ensure that the project is completed on time and within the budget. Effective project management is essential. It's very essential for ensuring the successful completion of projects in various fields. Project management is not just tailored to software engineering alone. It is open. It includes business, engineering, construction, and even in software development. So for those of you that want to understand project management, it is not just tailored to software alone. It is open to other fields of life. And what your job description will be is to plan, is to organize, oversee, and the whole project concept from conception to completion. So that's what project management is all about. Now let's look at programming. Programming is a process of designing, writing, testing, and maintaining computer programs to involve it involves creating instruction or code that a computer can understand and execute to perform a specific task or to solve a problem. Programmers are using programming language such as Java, such as Python, such as C++, and many others to write code and create software applications, websites, mobile app, games, and so on. So if you want to become a programmer, you need to understand how to write this programming language. Most programming language like Java, like Python, like C++, and some other programming language, depending on the field of programming you want to dive into. Now let's look at AI and machine learning. AI means artificial intelligence and machine learning. AI means artificial intelligence, like I said, and machine learning. They are two interrelated fields in computer science that involve creating systems that can perform tasks that usually require human intelligence. Machine learning involves developing algorithms and statistical models that can automatically identify patterns in data and use those patterns to make prediction or take action. Now, in machine learning, you know that you are dealing with data. So most times machine learning and AI, they are always going around data science. They are always going around data scientists. Some common application of machine learning includes image recognition, natural language and processing, and recommending systems. AI involves creating machines that can perform tasks that typically require human intelligence, such as understanding natural language, recognizing patterns, and making decisions. So AI, if you want to dive into the field of AI, or you want to go into machine learning, you need to also have mathematical understanding. Now let's look at cyber security. Cyber security refers to the practice of protecting computer systems, networks, devices, and sensitive information from unauthorized access, from theft, from damage or exploitation. So cybersecurity involves the use of technology, processes, and policies to ensure that confidentiality, integrity, and availability of data and systems. When you are dealing with cybersecurity, you are making sure that your systems are secured. They are secured from threats. They are secured from hackers, they are secured from from cyber criminals, insiders, and all those theft that goes on online. You are just protecting the whole structure of that your computer system, or it's an application to make sure that there is no theft or unauthorized access. Now let's look at UI UX. So if you want to dive into the field of cybersecurity, you can go into it if you are always after security, like you don't want things to get missing, you don't like people getting access into your computer system, in fact you found that people trying to hack data, you are good for cybersecurity. Now let's look at UI UX. UI means user interface, and UX means user experience, and they are two closely related concepts in software design and development. We have a UI designer, we also have a UX designer. So user interface, that is UI, it refers to the visual design of software application system, including the layout, the color, the color scheme, the typography, and other elements that determine how the user interacts with this software. User experience, on the other hand, which is UX, refers to the overall experience of using the software, including how easy or how difficult it is to navigate, how intuitive the design is, and how well it is to meet the user's needs. So if you know that you are good with colors, you are good with designs, you are good with lines, you are good with drawing, and you are good with understanding the flow of things, you can dive into the aspect of UI UX, so that you can be able to create good and quality software application programs that can meet the needs of users. Now let's look at data science. Data science. Data science is a field that involves the extraction, the analysis, and interpretation of large complex data sets using statistical and computational methods. It combines knowledge from various disciplines such as mathematics, such as computer science, and domain specific fields to gain insight and knowledge from data. The ultimate goal of a data scientist is to uncover patterns and insights that can be used to make better decisions, improve business operation, and even solve societal problems. So we can use data now to solve societal problems. We can use data now in data science to understand the pattern of how things has been and use that to solve societal problem. Data scientists, they use a variety of tools and techniques such as statistical modeling, machine learning algorithm, and data visualization to extract value from data. So we look at digital marketing now. So if you know you are good with data, you like data, you like playing with figures, you like playing with insights, you are good for data science. Just go and study data science. And you have flair for it, you can also go and study it. Now let's look at digital marketing. Digital marketing refers to the use of digital channels and tools to promote products, service, and brands. It involves using various online platforms and channels such as social media, email, search engines, and websites to create and engage with target audience. Now, digital marketing strategies may include activities such as search engine optimization, content marketing, pay-per-click, that is PPC, advertising, and social media marketing, email marketing, and influencer marketing. Now, the overall goal of this digital marketing is to increase brand awareness, drive website traffic, and generate leads, and ultimately increase sales and revenue. So the ultimate goal of advertising your products online, making social media engagement, is just to increase your sales and thereby increase your revenue. So if you know that you like digital marketing, you like using some search engines, you like using some social media, and you like engaging, you can go into digital marketing. Now, the last but not the least is software development. Software development refers to the process of designing, creating, testing, and maintaining software applications. It involves the use of programming languages such it involves the use of programming languages, tools, and framework to create software products that meet specific requirements and solve specific problems. The software development process typically includes steps such as planning, analysis, design, implementation, testing, and maintenance. It is an interactive process that involves collaboration between software developers, designers, quality assurance engineers, project managers, and stakeholders. Now, the end goal of software development is to create high quality software products that meet the needs of end users and achieve business objectives. So, in software development, it's not just about writing code, but you can see that there are some activities that come around software development, like like the activities of designers, UI/UX designers, quality assurance engineers, project managers, stakeholders, and you also have the engineers. The engineers that write the code. You have front-end engineers, back-end engineers. You also have the database engineers. All these people, they come together to make the software development process. So, if you know that you want to be in the software development process, you like the development life cycle, you can dive into software development. And I tell you, it's a very good and interesting field. You would like it if you want to. So, we have been able to look at 10 skills in demand: data visualization, quality assurance engineer, project management, programming, AI and machine learning, cyber security, UI UX, data science, digital marketing, and software development. And if you ask me, so you are trying to expose us into all this, you are trying to give us insight into this. What field are you in? And I will tell you the answer. I am a project manager. So I'm a project manager, and I manage software applications. So project management in software development.